The problem we are faced with is to provide relief to a disaster-affected community by providing food, water, and energy resources in a truck. Gaithersville was recently struck by a disaster, and groups of people need relief in the form of energy to power water pumps that will lead to providing clean, non-potable water, food irrigation pumping systems, and a way to charge basic electronics such as cell phones and laptops. We will create a system that will be able to put out at least 7 kilowatt hours per day, which will be sufficient to power the necessary water pumps and achieve the average charging requirements for laptops and cell phones. We initially considered wind, biogas, and solar energy as methods to meet the energy requirement of Gaithersville. We immediately discarded the concept of wind energy due to the fact that Gaithersville's low average wind speed would require prohibitively large turbine blade diameter to produce a meaningful amount of energy. Similarly, we dismissed the use of biogas because the low energy content and low expected amount of human waste would require too large of a reactor to meet Gaithersville's energy requirement. Ultimately, since we can meet our energy requirement using only solar panels, given our volumetric constraints, harnessing solar energy was chosen as our best option. We will provide a standalone energy production system that will charge our battery bank through the use of solar energy collected by a series of solar panels on the roof of the truck. Batteries will be used to store the solar energy captured during the day. This will be our source of power for our applications. The batteries remove the issue of what to do when there is less sunlight available, such as cloudy days or nighttime hours. The generator will only be used for emergency purposes and is not meant to be our primary source of energy. We want to minimize usage of the generator to save on fuel costs and reduce waste. We will supply the energy required to improve the quality of life in a disaster-affected community by supplying power for the cleaning of non-potable water, supplying power to an aquaponics system for food, and supplying power to charge basic electronics.